Hi, this is Linear Algebra 3.2. Apologies for a bit of a hiatus since my last video. There's been a lot going on, but hopefully I can catch up. And we still have some time, thanks to the reading week. So hopefully I can get this all done out of the way, and then we have ample amount of time to review and prep for the midterm that's coming up on next Monday. So. And some of the some of our classes we took it earlier, so for you guys, I guess you won't be visiting here, but nonetheless, it might be good review for the final if you'd like. But anyway, so jumping into 3.2, 1a. So we are introduced with the concept of norm, and norm basically is a number, is a magnitude distance between two vectors. Later on, we can't just be happy with the norm between vectors. We actually have to find the vector in between and do calculations on that. But that's like 3.4 plus. So that's that's like 3.5, 3.6 later on. So you don't have to really worry about that just yet. Not for this midterm anyway. We'll get there. So I think people sort of get it, but I think a good analogy that maybe I could try to use, think of norm as a tangent perhaps, right? So, or like, you know, how do you calculate the tangent, right? So usually you're given quadratic for calculus 1. That may not be the case, but the point is you have the original function of something, whether it's quadratic or cubic or whatever, and then basically you find the derivative of that, and then you get the derived function, which happens to be a tangent equation, right? But the problem, well, not the problem per se, but the tangent equation, right? And the tangent function is still a function. It is not a, it's not a line. It's all possible tangents. So okay, so I'm gonna write it. Hopefully I can write here. So if this is a function, right? So when we've derived it, it's all the possible tangents. See, all the things I'm writing, right? Anything that touches the function by 1, all those lines, right? All those linear lines representing all the possibility is what a tangent function is. So norm is anything but that, right? And for norm, it's a very specific distance between two vectors. So just like tangent function, in order because tangent function itself is useless, we need to find out like which tangent line that's going to be useful to us, right? So what we want to do is all the similarities between these tangents is that they're all touching the function by one intercept, only one intercept, right? So if we tell them, okay, where we want intercept to be, let's say here, right? There is only one unique tangent function that fits the portfolio, and that happens to be a very specific line. So think of it that way, perhaps, if that makes any sense. Maybe I'm going insane. I constantly have to do sanity check from time to time. But so think of it like that, right? So between vectors, there are all sorts of possibilities, right? Because they're moving and they're speed with directions, right? But we are looking for a very specific one that we only care about, and that's the norm. That's one of the ways to calculate norm. So there's that. But nonetheless, if that didn't make sense, don't worry. As long as we can solve the questions, that's all that matters. But for people who like to make the sense of this conceptually, I thought I'll bring that up. Anyways, so going back, so if I intimidated you, the questions will be less intimidated. So we have this vector 2, 2, 2, right? So it's going x in x direction by 2, y direction by 2, and z direction by 2. And basically, we're asked to find the norm and find the unit vector. So norm, we use this notation, right? You've probably seen these already. And so basically, all this means is it's just like the Pythagorean theorem, sort of, right? So you just add all the components after you square them, yeah? And then you just square root it. That's all there is, right? So 2, 2, 2, so it's going to be 2 squared, 2 squared, 2 squared, square root all that, square root all the sum inside, and you have square root of 12. Now, because simplification isn't exactly the most important thing, right? In linear algebra, you probably noticed that too, right? So you can just leave it like this, but for some people, maybe you want to reduce it further. Reduce it when appropriate, right? So if it will make your life easier. So if I have 2 and then you have 2's on the top or something, or 4 or something like that, that will make your life easier because it will simplify the numbers. But if it doesn't, then why bother, right? Just write the answer. It's not wrong. So, prioritize, right? Quite often I hear like people sometimes run out of time for a midterm. So, improvise depending on how much time you have. But the important thing is you get here. After that is optional, right? So, unit vector. So unit vector is 1 over v norm times the vector itself, right? So nothing too hard. So we've just found out the v norm, right? Which is 2 square root 3 or square root 12, doesn't matter which one you use. So it's going to be 1 over that we just found times the vector itself, 2, 2, 2. And all you have to just times it here and times it there and times it there, right? So since they're all 2's, hey, interesting, there's a 2 at the bottom, right? So that's why I reduce it, because 2 will cancel out nicely. So you're going to have, well, ignore this, it just means 2 and 2 will cancel. So it will be just 1 over square root of 3, 1 square root of 3, 1 square root of 3. So, not rocket science. When it says oppositely directed, that's a fancy way of saying opposite direction, right? Because vector, if it's going this way, you could have another vector that has the same magnitude but going the opposite direction, right? My hands, aren't working, but that's the idea, right? So the only difference you have to do, because magnitudes are the same, we don't change anything except the sign in front. So right here, so you have negative, right? So just stick a negative in there, and that it just means it's going in the opposite direction. Remember, it's like speed with different direction. We learned it in physics 20 and 30, if you guys ever took it. But nonetheless, so all what happen is magnitude will be the same, but you'll just reverse the signs. That's all it is. Anyways, so not too difficult concept. I did use your solution key to check 1b, and I did the 2b, just to make sure that we're comfortable. But it's a relatively simple concept. So here's my 2b, if you will. So there's 2 possibilities, this or this. I ran out of room, but these 2 are the same thing, but the signs have been flipped, if you will. So we will get into 3. Okay, so moving on to question 3 and 4. So it's a similar idea, not too bad, but now the only thing is we're now combining number of vectors algebraically. So so we have 3 vectors as shown over here. And then the first question, 3a, is saying, well, what's the norm of vector u plus vector v, right? So we add them. So there's 2 ways to go about with this. If you like, you can just, cram everything in one expression, right? So basically it's u plus v, right? So u plus v. So first entry, 2, 1, right? So that's going to be 3 right there, right? So -2, -3, add them together, it's made -5, and so forth, right? So this is ideal way to go about it, because for most of the part, it's relatively plain straightforward in terms of additions. So this is what I would recommend. However, remember COMSI, right? Polio, right? Divide and conquer concept, right? So there's another way is do the overall net vector first. So add the vectors first, and that new vector will be this, right? So then you just norm this whole thing, and then it will be much easier, right? So for simple numbers like this, one way or the other doesn't really matter with me. I'd rather just do everything on one step. But I've made some mistakes before. So if you really want to play safe, use use the latter option. However, if the expressions gets really complicated, so here's really relatively simple. So it's like u plus v or something like that, right? But later on, you'll see 4 or other 3d, for instance, right? A lot of numbers coming hand in hand, right? So that may not be ideal for some of you, right? So improvise. Second is a little bit safer because you're breaking down steps 1 at a time, so less margin for error. But sometimes, why bother, right? Like if it's 1 plus 1, I'm gonna remember 2 square and square root that. That's pretty simple to me, right? So I'll let you decide. But anyways, here are the answers. So but it doesn't matter what you do. Either way, you get the same thing. Here, I just add it all in here and then square root it, or you could just add those to get a new vector and then square root just this overall vector, which happens to be this half. So relatively simple. D, again, same idea. It's just algebraic a little bit more complex because we're just doing more operations, but it's the same idea, right? So u vector here, right? So times all these entries by 3. So this is how I did it, right? So u sorry, let's start one at a time, right? So first one is u. 2 times 3 is 6, right? So that's gonna be 6 minus 1 times 5, so that's minus 5, right? And then plus w. W is 3. So 6 minus 5 plus 3 is gonna give me 4. So I put 4 here. And I just did the same thing for the rest, right? Just make sure you don't get confused with the square, you don't make a mistake, right? If it's a negative number, remember you have to square root it. We do not want to see any negatives under the square root, right? So make sure, right? If you're subtracting or if the number gets smaller, you did something wrong. So anyways, if you do all that, you get this answer, right? Simplify it if you like, it's up to you. For C, this is where simplification may or may not be handy, depending on the circumstance. So if you look at here, it's 3v inside the norm minus 3, which is outside of the v norm, right? So, so here it just means I'm going to find the net vector first. So v is right here. So I'm just going to times all the entries by 3. So there it is. So 3, 9, and 12, right? So 3, 9, 12. I understand this is negative, but because we're squaring it and square rooting it anyway, who cares what the sign is? Make sure they're all positive, right? So this one, I put the 3 out of the way, right? Because that's not inside the square root. 3 is not inside the norm, right? So I took the 3 out of the way and then just define the norm for the regular vector v. So 1, negative 3, 4. No, 4, right? So if I did that, I get these, right? So normally, I mean, unless they specify otherwise, this is where you would stop, right? Because, hey, I got my answers, right? It may not be the simplified form, but who cares, right? But for this particular situation, just because I happen to know, I know that because we're squaring it and then square rooting it, whether you put the 3 inside or the outside, it really shouldn't matter magnitude-wise, right? So because of that, I realized, okay, these and these should be about the same. So what's a hint? Well, this is has a 26 square root, right? Maybe I can divide 234 divided by 26, and it will come out even. It will divide up evenly. So my suspicion came true because 234 is a product of 9 and 26. 9 you can square root that and simplify it to 3, right? So I have 3, same thing. Hey, these two are identical. So subtract them together, you got 0, right? So, yeah. So, is this required? No. But depending on what kind of questions you're gonna get, right? So they say like, use this to explain the relationship or something like that. You want this, right? Because 0 tells you more meaningful application. 0 will give you a better answer application-wise than this expression, right? So for our school purposes, I don't think this is something you have to worry about since I already wrote this, the third quiz. But for other professors or other schools, this may be what you expected. So I'll let you decide. But conceptually, not that difficult. Okay, let's go into number 5. Okay, so this is question 5. I'm focusing on C because A and B are relatively similar to the questions we've done so far. So this is a weird one. Just because it just looks differently, but it's the same concept. So we have 2 vectors, and then this is an expression. This looks weird because they're all crammed together, right? But if I just expanded it, visually so that it will look like this. So these 2 are not both in norm, right? So outside and outside. So if you get rid of that, V is not normed yet, right? So it will be eventually, but nonetheless. Right? So you have this and this, which are uniquely different. This is normans already within, and this is now. So, anyways, I think I made the point clear. So how I started off is this is where I would do divide and conquer strategy. So I'm gonna calculate this one first. So that's gonna be and you have that nothing new, right? We just got u from here and then so forth. Yeah. So anyways, so now that I got rid of this and there's a negative in front, so I'm just gonna sub it in such, right? So this is the same thing as this and this, right? So because of that, think of this as an absolute value, right? So, or you could do this, it really doesn't matter. So you have one entry, right? So you could just say, well, it's going to be a square root of negative 46 square root square. So these 2 are just going to cancel out. So because of that, that's just going to become positive 46, right? So If you square it and square root it, they're gonna like cancel each other. Kind of like ln and e, if you will, right? So because of that, they're gonna be positive. So technically speaking, you could look at it as an absolute value, if you will. It's not quite the same, but it has a similar effect for this particular case. Anywho, so then you have the norm v, right? Norm v, and then you just find norm v, just like how we found out norm u, and then you have these two expressions times them together, and you're gonna get this fat square root number. Yeah. So that's all there is. Move on to question 6. Okay, so we're back to question 6 and 7. Let's start with B with this one because I just want you guys to get familiar with norm within a norm, right? So, follow through. The U and V vector entries are mentioned in the earlier question, right? The V is right here, or just look at your textbook, up to you. But nonetheless, so I did the net vector to of U and V vector difference. So I have that. So this is the same thing as this. Then I plug this thing in there, right? So that it becomes 14. W is also here. This is the same thing as this. And here, again, is a number. So square that and square root it. So it will just get the same thing. And then the norm of W. Done, right? So, nothing too difficult. 7, similar idea. Yeah, so actually it's the same idea. Now that I taught you this, I solved the problem this way. This should be piece of cake. In the solutions, they don't make these very clear. So some people might get confused, but if you follow through this should be piece of cake. So you have that, you have KB, inside the norm is 5. We already said this is the same thing as this, right? Right, so it's just a norm of k and norm of v, and as you know, k is just a number of whatever it is, so square that and square root is just going to be the same thing. Again, but it has a absolute value effect because you have to square it and then square it, which means it will be positive no matter what. Any negative number, if you square it, it's going to be positive, right? So because of that, k is going to be always positive. V is, and we have to find out v. V's multiplication will give me 5, as we said, right? So I apologize if it looks a little distracting, but mathematically these are correct. So all you have to know is kv equals to 5, like it says here. So k, I don't know, but I'm gonna find the norm of v. The v is here. Just do that. The only tricky part is here. You have square root of 49, which could be 7, right? But remember, 7 times 7 is 49, but negative 7 times negative 7 is also 49 too. So it could be positive or negative, right? So if you isolate for the k is going to be 5 over 7 or negative 5 over 7, right? So just watch out for the square root thing. Whenever you square root something, that gives you positive or negative, because positive times positive will give you the same thing as negative times negative. Anywho, so that's that. We are going to jump to number 8. Okay, so this is question 8 and question 9. Again, question 8 is similar, right? So I'll just let you follow through. The only difference though, on the question it specifically said I want a scalar k, right? Yeah, scalar k. So because of that, so I just did that regular thing, and when you square root things, square root this, it's going to be plus or minus negative 4. So technically, if you divide it up, 4 divided by 4. Or 4 divided by negative 4 is going to give you k equals to positive or negative 1, right? But k must be 1 because it's got to be scalar. Scalar is like magnitude. It's like, remember the scale versus vector we learned in physics 20 and 30? If you guys ever taken it, like distance, displacement, speed, vector, so forth. So yeah, so scalar just is a fancy way of saying make an absolute of it. Okay, I want distance. Like you can't have a negative distance. Or and so forth. So because of that, or you can't have a negative speed. You can have a negative vector, right? Because speed is vector. Vector is speed with direction, but speed itself is magnitude. So if someone says negative 50 kilometers per hour, they figured out time travel, right? So anyways, so that's number 8. Number 9, we are going to be introduced with the concept of dot product, right? So dot product is relatively obvious because you see this big dot, not just regular small dot that we use, a big dot that represents the dot product. There's a bunch of variety of different dot products. I haven't had a really chance to look at it, but apparently there's different variants. For now, though, we will be just using one type of dot product, which Euclidean dot product, I think that's what's called. But nonetheless, so you have that. So all you're doing is just timesing each of the entries with the same position, and then just sum it all up, right? So here, you're doing vector u times vector u and vector v in dot in a dot product. You're going to find the dot product of u vector and v vector, right? So if that's the case, the first entry is 3 and 2, right? So you times those. And the second entry is 1 and 2. So just like what we learned in computer science, positioning is what's important here, right? So 3 times 2 and 1 times 2 and 4 times -4, that will give you -8. And the rest of it is relatively straightforward. It's the same idea, right? Just make sure you multiply entries with the same position and then keep going until your entries are all multiplied and then just bash them and add them together, right? So that's what 9 is. We will proceed to the next question. Okay, question 10. So this one, again, is relatively simple, another dot product. I just did a few just to make sure you guys are comfortable with it. But nonetheless, yeah. Oh, another thing that I need to emphasize is that the result of the dot product, right, must be a number. Cannot be a vector, right? So you're multiplying vector, but your result must be a singular number, right? So just be aware, right? So for example, here I did that and you got 0, right? It's not 0 vector, it's 0, like, just a number, right? So be careful, right? You get rid of the vectorial component, vectorial characteristic when you do a dot product, right? And that may or may not mean something to you depending on what kind of questions you get. But just be aware of that concept, right? 11, we're gonna be introduced to a new concept with a new formula. Cos angle equals to u vector times a dot product of u and v vectors divided by the u v norms, right? So relatively straightforward. Now we know how to do dot product, we know how to find the norm, so just punch it through just like what we did, right? These are the two vectors. I apologize for being a little disorganized, but u and v, they have components, so 3 1 3 0 3 4, right? By positions, right? So that's that. And then u and v vector component, so these are the norms, so just find 3 squared, 3 3 3, so they're gonna be all squared, added up and square rooted. Same here. So you're gonna get 15 over negative 459. Now, this was, by the way, also on the quiz 3 for our class. Chances are you might get it. Hopefully, I will also be able to put in a quiz review for some of the students who haven't wrote down midterm. Who haven't had a chance to write a quiz yet. Next Monday, I believe. So hopefully, I can make that happen. But nonetheless, so you have that. These are the 3 things you should try to appreciate. So on the dot product, remember, cos has to be between -1 and 1. If you remember the unit circles, right? If you use your graphic calculator, whatever calculator, and you try to punch in any number that is bigger than 1 or -1, you'll get some kind of an error, right? So it's got to be in between. So all we care about is well, not all we care about, but the critical value for cosine, or sine really, is going to be, actually no, for cosine specifically, for sine it's 1, but for cosine it's going to be 0, right? So at 0, when cos is 0, it's perfectly at 90 degrees, because cos of 0 is 1. Yeah, exactly. We can talk about the unit circle in a bit, but basically, just know for now, I will go. Actually, do we need to go through this? Okay, hopefully you guys are comfortable with unit circles by now, but I'll talk about it if I need to. Anyways, you have u and v, so if you times u and v on the top, we don't care about the bottom really. And the only time when we have to worry about if it gives us negative, but you know it can't give us negative, right? Because norm of anything is going to give you a positive number, always, always, always. So positive times positive is always going to give you a positive, right? So we don't really have to worry about it. To be honest, you don't even have to calculate this if you don't want to. Calculate this though if they are asking for this value, right? So improvise depending on the question. But all we really care about is the dot product on the top, really, right? So we get the dot product, and if it equals to 0, if the top is 0, then 0 divided by anything is 0. So it's going to be, the angle is going to be always 90 degrees, or right angle, right? Now, if the dot product happens to be greater than 0, then we say it's acute. Acute is anything between 0 to 90. So anywhere between 0 to 90, like say 89 degrees, 60 degrees, that's acute, right? Like that. Until it becomes right angle, right? So if I go further though, right? Or like think of it this way, right? Anything greater than 90 degrees but within 180 degrees, right? So between 90 to 180 degrees, right? So it's like acute on the opposite side, right? If you will, right? But nonetheless, that's what we call obtuse, and that happens when the dot product of u, a vector u and v is less than 0. So, so it's got to be a negative number, right? So the top is going to be negative. Right? So appreciate these rules. These will save you a lot of time. Now, if you, let's say you wanted to double check, or maybe the question was saying, well, no, I don't care, I want to get the angle, right? Then you do need to just calculate both of them, and then, in this case, I got 15 over 15 over square root of 459. So just, depending on what calculator you have, usually the function you're looking for is cos -1 or something like that, right? So depending on what calculator you have. So for example, actually you guys should all know this, you guys all take it math, right? So for my calculator, it will be cos -1 here, right? So press the yellow button and so forth, right? But basically, that's all you do. And then you punch it in, and then it will give you the angle of 45.66. I think we're at a point where sig fig doesn't really matter, but I'll let you decide how that works, right? So, but the point is 45, 46 degrees, however you want to say it, right? Which is acute angle, right? And we know it was acute angle before we even calculated this because the dot product happens to be 15, which is greater than 0, so it must be acute. So that's what you are expected to know. Okay, so that's question 11. Let's keep pushing. Okay, so we are gonna. Oh, I haven't quite finished it. Anyways, doesn't matter. I haven't quite question 11a. I haven't quite finished it because they're also asking for a distance. The solution gives us this, but I didn't really bother doing this. Up to you. This was also on the third quiz for our class anyway, by the way. And I didn't bother du, comma v, and it still went through. And I have Maria as a prof, so if she says it's cool, then mathematically, yeah, I must have said it. I said it right. What I did right though, I started off here. Vector. If you don't see, if I say vector and it doesn't have that line on it, that means I didn't write it. You should have an arrow, right? Otherwise, it could be a just random variable where it could be scalar or vector. It doesn't matter, right? So nonetheless, we have the u and the v. I give you the u v vector entries components a while ago. So we've done this before, right? So just make sure you're familiar with it. You're familiar with this, right? This concept, right? So norm is a distance between two vectors, right? Or magnitude or whatever, right? So not distance between two vectors. Here is distance between two vectors, but if you just have a vector and then you norm it, right? It's just a magnitude or the number of a vector or distance of the vector itself, possibly, right? So that's that. That's that. Number 13. This is where it gets it looks intimidating, but it really isn't. I just put a lot of steps in a really small space. That's why it looks weird. But nonetheless, so visually, let's try to understand what this means, right? Because on the question it says, suppose a vector A is an xy plane. So typical Cartesian graph that we're familiar with, right? X and y, and then basically it says the vector A has a length of 9 units and points to direction 120 degrees counterclockwise from the positive x-axis. So from the positive x-axis, I go 120 degrees counterclockwise, right? So that just means clock is going always this way, right? Or is a video showing, right? But you know which the direction the clock is moving, right? So it's the opposite. So that's why I'm from here all the way up to here. And the whole thing is 120 degrees. Fair enough. Next one is vector B. It says it has vector B in this plane, in this Cartesian graph, it has a length of 5 units and points in the positive y direction. Where's the positive y direction? Up, right? So it goes here. So so basically what is it asking? Find dot product of A and B, right? So because we're looking for just between A and B vector, right? So we don't care about 120 degrees. We want between A and B. Where's A? A is right here, B is right there, right? So if you magnify the triangle, this just means, remember, up from X to Y, right? From regular positive X to the positive Y, which is where the B is, by the way. sec. My apologies. I just got a phone call from a client who was hoping to see me again. But okay, but that's irrelevant. So where were we? Okay, so that's why we said, so we only care about the angle between vector A and vector B. So because of that, so we don't care about this 90 degrees, right? That's irrelevant. All I care is between A and B. So because of that, 90 degrees is taken out. So what the angle just left after you take the 90 out is going to be 30 degrees. So that's where they got that number. For some of us, that's common sense, but this may clear up some confusion for some of you. So we got the angle. Cool. Okay, so now the rest is simple, right? I apologize for squeezing it. I just had to make the room for this unit circle, which I will get into. So cos angle is equal to dot product of vector u and v divided by norm of u and v, right? So we did that before. So I just rearranged it because we're looking for dot product of u and v, right? So I just use cross multiplication. This times this will always equal to this times the whatever is below, right? So because of that, so that's going to be just u dot product is going to equal to this times that, right? And that's so, and we don't, so then they gave us the unit distance, right? So they already gave us, so it's going to be just 9 square square root 5 square square root times cos 30. So if you punch in the calculator, it will give you 38.9 blah 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 blah. To me, that should be good enough answer. In calculus, maybe not. I'm not sure what your prof is expecting, but some may be asking for a more precise answer. So how do we go about getting a precise answer? I mean, this is a nice number. This is a nice number. Cos, that's you can't really have control over that. It's just punching on a calculator, right? But there is a way you can do, and that's what we call the unit circle. For people who have taken Math 30, this should be pretty straightforward to you. But nonetheless. So just as a quick review, so this is sort of what the unit circle looks like. And so the only angles you really need to know is 30, 45, and 60 for now, right? Obviously, this is just the most popular ones. Technically, whether it's 50 degrees or 89 degrees, they all have their own x and y components. But for now, these are the threes that they expect us to know, right? So, so this flat one is going to be 0 degrees, and that y is going to be perfect 90 degrees, right? So anything between 30, 45, 60, those are the degrees as well. So as common sense tells us that, assuming that this circle has a radius of 1, right? So x is going to have x of y. So it's a radius here, right? So that's going to be x, position is going to be 1. 0 is going to be, so y is going to be the 0 because it didn't go up or down, right? Remember, x is like left and right, and y is up and down, right? So it has a radius of 1, but it didn't go up or down, so it's going to be 0 for the y component, right? Let's look at the 30 degrees. For 30 degrees, this you just have to memorize, right? Square root of 3 over 2 is going to be your x, and y component is going to be 1 over 2. It sounds misleading because if y is 1 over 2, it should be like up there. So that's just my horrible graphing skills. But nonetheless, right? So, and that's the unit for that, square root 2 and square root 2. Notice that y-x components have the exact same magnitude of number. This is because it's 45 degrees. If you're 45 degrees, your x and y should be exactly the same. It should be like a triangle with, two same sides, right? X and y, right? So, just be aware of that. 60 degrees is just really 30 degrees flipped upside down, right? So because of that, our x and y is going to flip. That's all there is, right? So, and then so forth. So, or for our particular example, we're looking for cos 30, right? Cos is x, as our prof always said, and sine is y. Just think of it that way, right? Or use whatever method you need to make it stick. But so, because we're looking for cos, we're at 30 degrees, so we look at 30 degrees and look for x component, which is the square root of 3 over 2. That's how they got the number. So it's got to be 9 times 5 times square root of 3 over 2. And that's how, then if you do that, you'll get a more precise answer. Now, your teacher may care or may not care. I personally don't care, unless I want you to know these. Up to you. But now that you have these, you should know, right? Oh, by the way, if it's y at 90 degrees, right? So remember, so degrees is 90 now, right? So has the x in the x component, did it move left or right? Not really. It's still in the center, right? Because of that, the x component is 0. But but y component is 1 because it went up by 1, right? Now, let's use this concept and go to the other parts of the angle. Let's say it was 45 degrees this way. So if you total all up, so that's 90, 180, and then 180 plus 45 is 225, right? So at 225, the x and y component is going to be same thing as this, but remember, this is positive x and positive y. Here, look at here, it's going down, going left. So it's going to be negative y and negative x, right? Because of that, sign's just going to change. So it's going to be the exact same number, but it's going to have negative on both sides. That's all there is. If you look at this guy, right, 270 degrees, right? The same thing as this guy, 90 degrees, but went down, right? So because of that, this at 270 is going to be, sorry, I'll be right there, and it's going to be negative, answer 0 and negative 1. That's all there is. Moving on to the next question. Okay, so this is question 14. Again, very similar to 13, but you know, for sanity check purposes, if any one of you guys are working on this. But again, so the only difference with 13 is that it's the direction of the vector. So vector A is in the xy plane pointing in a direction that's 47 degrees counterclockwise from positive x-axis. So x-axis and basically 47 degrees counterclockwise. But the v vector is 43 degrees clockwise. So now we're going like a clock, right? So we're going under. So the gap between that is 92 degrees, right? So that should mean something to you, but we'll find out. So we're gonna use cos and this too, right? As usual. Oh, by the way, the notation, you know, just, you know, if I really wouldn't worry about it, but you know, in case you gotta pick a teacher, make sure u and v are, you know, set. So here, what I did, right? Vector a and b, I said let vector u equal to vector a because you're using these, but you haven't declared any of these, right? So we see a and b, but what's vector u or vector v? We don't know, right? So, you know, just either do this, or you know, or if you don't want to go through that hassle, just say cos theta equals to a vector a and vector b dot product, so forth, right? So improvise, you know. But anyways, that's there you have it. And then I'm just going through this. Now, like we talked about in question 13, norm of u and v are always going to be positive. Cos 92, however, is negative. And if you remember the unit circle, you should know why, right? Because if you have a unit circle like this, now you're above 90 degrees, right? So you went this way. So in terms of x-axis, you're no longer on the positive side because you're 92 degrees, like around here, right? So now that small area, that's going to be your negative x, right? So because of that, you're going to have a negative value. Does that sort of make sense? Because this is positive. If you go beyond 0 towards left, it becomes negative, right? So you have negative here. Negative times positive is always going to give you a negative number. And if you have a negative number, that means dot product of u and v vector are going to be less than 0. And remember the rule, the 3 rules we talked about? Look back at it and you'll realize that means the angle in between these two vectors must be obtuse. Now that question sounds a little bit stupid because we already know it's 92 degrees. We know it's already obtuse, right? But you know, getting comfortable with the notion of these is the idea. Later on, you may not have degrees, you may have something else. So you have to solely rely on this to determine whether it's obtuse, right angle, or acute. So this will be on test. So, well, probably. It was on our quiz. So hopefully, you are comfortable with this. On to question 15. Okay, so this is 15 and 16. So just playing around with the concept of dot product and norms and so forth, just to make sure. So the only thing we need to know from this information is that there is a difference between vector and norm, or just any regular number, and vector and number cannot be multiplied together. That cannot happen. The only exception is the unit vector, which we talked about, but we're not talking about that. General scheme of things, vector and norm are not multiplied together. Never. So let's take a look at it. So A, so have that in mind, and then we'll look at 15. A is going to be vector, and that's the dot product vector v and vector w, right? So remember, this is a dot product, so we have to do this first because of the parentheses, right? So because of that, remember what's the byproduct of dot product is going to be always going to be number, right? Number. So that's a number. Number times vector? Absolutely not in the dot product, right? So no, dot product has to be two vectors multiply and gives you a number, right? So because of the A can't be, right? So big X. Okay, so the 15b vector u dot product that. Now here's the thing though. What is this? Vector plus vector. So what's vector plus vector? Another vector, right? Net vector, if you will, right? So can I do dot product of a net vector and a u vector? Yes, we can, because the requirement for dot product is two products that are being multiplied has to be vector, and it will give you a number. I buy that. That's vector. That's vector. Good to go. C. Yeah, that's also legit because dot product. Now, do I have two vectors? We totally do, and we have that, and that's gonna be number. We can do a norm of a number, which is fine. We've done that before, right? It's like absolute value, right? So it would always be a positive number. But this is good. And this is good. Okay, the next one is going to be D. And that... Oh yeah, sorry, my bad. Sorry, no, cough. Okay, sorry. 15C. Okay, I must have been staying up for too long. Okay, so the problem with this is this. So you're gonna have so for the let's see here. So yeah, okay, never mind. Yeah, so you have to be very careful about this. Sorry, I made almost a mistake. So inside a norm. So if it's scalar, it's possible, right? So remember, yeah, so, how do I explain this well? Okay, so this one doesn't make sense, and I'll tell you why. So, because when you have a dot product, you're gonna have a number, right? So that number, that's going to be a number, and according to the definition, norm, anything inside the norm has to be a vector, or, now, this is where I got a little bit confused. But in the last questions we've been doing, we were able to get a constant and just do a vector. No, sorry, we can get a constant inside a norm, and we just did it, right? Treat it as an absolute, right? So that wasn't 100% clear. Okay, so I should have been made it more clear. So that number is only possible because that number is a coefficient of the vector. Inside the norm, every component must be a vector, right? So remember, it was like, I don't know what it was, but basically it was like 9 and then some vector or something like that. Oh yeah, remember questions like this? So I think it was like u and v and the whole inside vector, right? So if I do that, that's a number, right? So number can't be inside a norm. Isn't that what you just said, right? True, but this number is tied to the vector, right? So because of that, this whole thing is a vector, right? So that's why it was able to get, we could get away with it. If it was, for example, let's say, for example, if it was that, then it wouldn't work. It would not work because you have a number. Okay, apart from the fact that number plus, okay, better example. Because you know, like, okay, by the way, you know this won't work, right? Because you're trying to add number with a vector. So can't do that. But even if we had this situation, let's see, let's say it was that, right? Yeah, so that won't work because it will be number plus number, that's fine. But number inside a norm cannot be. So if there is a number inside a norm, it better be touched. It better be stuck with a vector. That's the only way, right? So that's the condition. Inside a norm must be a vector, right? So, sorry about that. But anyway, so that's incorrect. And so bear that in mind when we do this. Dot product of that's going to be number. Norm of a vector is going to be a number. Number minus number is going to be, yep, it'll be fine. Here, this question they ask you if this is going to be vector or scalar. Well, we already said. Dot product of this vector and this net vector will be not just a number, so that's scalar. This one's also scalar because if you do a dot product of that, it's going to be number. Number minus number is going to be a number. Scalar, right? Alright, so try number 6 on your own. Pause the video a little bit and then I'll go through it as well, right? For sanity check purposes. 16a. Okay, so I'm assuming you stopped. Stopped and worked it out by now. So 16a. So you have can we do a dot product of a number? We can't. No way. We can't do that, right? So yeah, so dot product, it has to be vectors only, and then it will give you the resultant number. But yeah, can't do these. So dot product that, yeah, we can do that. So that's gonna be a number. Number minus vector, no. So dot product of two vectors, cool. That's a number. Number minus number, yeah, we can. So that's gonna be scalar too, right? So d k times. Oh wait, hold on. Is it dot product? Yeah. So if it's just k times u, we can get away with it. So that will be a check mark. But so this will be check mark. But if it's k product, dot product of a vector, so this gotta be vector too, right? So that's why this will fail. So this is the actual d. But if you had a question like that, right? So. Or like, I don't know, you could do this, but usually we don't like to use this a lot, right? Because some people might say, well, it does an x. So, but you get the idea, right? Just regular multiplication works. We did that all the time. Remember when we were doing the vector that parallel and goes to different direction? All we have to do is times it by -1, right? So we can do it, it's just not for dot products, okay? So that's 15, almost done, 16 and 17, and we are good to go. Okay, so this is the last question. Okay, so 17a. So we have these two vectors, and basically, what does the question say? So the question is just asking, verify that Cauchy-Schwarz inequality holds. Now, what does that exactly mean? I mean, you know, okay, got it. If you look at your notes or whatever, you will say the Cauchy-Schwarz equation has something to do with this equation, right? So if this is true, then you know. Cauchy-Schwarz inequality holds. So we get that. What does this really mean though? If you actually read the book a little bit, basically it just says if the vector u and vector v are vectors in Rn, which is the plane, right? So the reason why we bothered to check this, because like why would we be bothered? Because this is something related to the cosine thing, right? What do we care about? Because then John said vector u and normal u and v are always positive and so forth. So why do we need to worry about this? Like, because this is going to be positive, and that's also going to be, that may or may not be positive, right? So, like, why does this matter? I thought what we have to worry about is vector u, dot product of u and v, and then that would tell us whether it's obtuse, acute, or right angle. Like, why, right? So the reason why we check this, which is we should check this every time, but we don't bother because of our level. But the reason why we need to check this is because those two vectors, right, may not be on the same plane, right? So this checks if they're on the same plane. Because if they're not on the same plane, then we cannot just simply find the angle in between. Because we can only find angles if they're on the same plane. So if it's like this, x and y, right, then we can just find the angle between. But if I'm going this way, sideways towards z, right? So if that was the case, then, you know, how do we calculate the angle, right? It's not one dimension anymore. So that's why we need to check this, and that's what that's called Cauchy-Schwarz inequality. So that simply means if it passes, it means both of them are on the same plane. Then we can proceed with the trick formula that we were using earlier. So anyways, but that idea is the only tricky part, but apart from that, relatively straightforward. We did the dot products. Oh, by the way, this is a... So let me just check the equation, just to do my translation check. So that is not the norm, that is the absolute value, right? So, okay, so let's check it out, right? So that's gonna be, so I'm gonna do a dot product of these two vectors, so that. So it's gotta be -7, I know, but I'm gonna put it at 7 because it's inside the absolute value, right? So that's gonna be 7. I calculate this separately as shown here. We should be comfortable with norms by now, so when we calculate them all, we're gonna have this, right? Which happens to be 140, I didn't write it down. But well, it's right here, right? Whatever, 140, right? So because of that, so now we're gonna do a comparison. Now, you could just punch it in calculator, square root of 140, and we'll give you some decimal numbers, and that will show that it is greater than 7. But, you know, how the textbook did is, well, let's just make it into square root so that we can compare better, right? So doesn't matter how you do it. punch in square root of 140 and look at the actual number, or just make 7 become square root, just like this, right? 7 times 7 is 49, right? So I'll do it that way, right? I don't like, well, actually, no, whatever. It works just fine. So if I do it this way, then you say, yes, that condition is true, because 140 is totally bigger than 49, so Cauchy-Schwarz inequality holds. I'll try the... Should I bother trying out the B? I mean, B is going to be the same thing, right? So, like, you're doing the same thing except you have one more entry, right? So, I'm hoping to upload the other one ASAP, so I'm gonna just skip that one. But hopefully this gives you a good idea, right? For 17B, let me say this again, the only difference is that we have one more entry in the vector, right? So it's gonna be -3, 1, 0, and something else, right? So you're just gonna have, so for this one is 1, 2, 3, you're gonna have another one, right? For the last entry, so if it was 0 and 0, right? Not square root. Okay, so that, and that's gonna be that. So let's say it was that, right? So that's just gonna be added at the end of the dot product, and this is gonna be added at the end of each of them, right? But again, it's the same idea, right? So practice B2. You should have a solution key. For people who do not have the solution key, you know, because you know. Some of them may choose to just stick with this rather than using the book. So, I'll just write down the answer quickly. It's gonna be, where'd you go? So, for that case, I'm just copying down the answer, okay? So, UV is going to be 7, and UV is gonna be, no, I lied. It's gonna be 36. Sorry about that. It's gonna be 5. 5. Okay, so because of that, so yeah. So again, so that's gonna be UV is, that was a condition, right? So that's gonna be 5, and square root of 36 is just 6. Very true. Right? So it also holds as well, right? So we didn't get this on a quiz, but you know, because you know, Ganesh or Carlos may have a different idea, so you know, make sure you just know it, right? So yeah, and if they ask you what does it means, you know now what it means, right? Not on the same plane. Anyways, so that wraps up 3.2. I will start 3.3 right away. Yeah, just taking, yeah, I have to tutor in between, so I should have got this done a little earlier. But anyways, I will see you back in 3.3, so we'll see each other.